Hello guys, welcome back to the VDC space. Sorry about the video I uploaded yesterday. Something was wrong with it, so I managed to do another one. So, like I said, we're gonna do a pedestrian bridge, and this is how it looks, the final product. So I'm only gonna cover the only the body of the bridge. So essentially, the walkways are just use floors, and then you can just attach railings towards those floors. So let's start with our project. The first thing is just open up the construction template, and we're just gonna expand our views and elevations. So, and then we're gonna establish our grid. So we're gonna place one grid horizontally like this, another one diagonally like this. And then we're just gonna go to our dimensions, place an angular dimension right there, select the diagonal grid, and then reduce the angle, make it 5 degrees. And we're just gonna rename this grid to CL for center line and press enter. And we're gonna go to grid again, place vertical grids, and then this one we're gonna name it abutment A, and then you're gonna select your grid again and then pick lines, and then you're gonna offset it by 25,000 millimeters. So let's just adjust this. So essentially our abutment is gonna be placed on this point and then another one on this point. Now it's time to establish our truss. So for that, you're gonna go to file and say new and then family. And we're gonna go with metric structural trusses and then say open. So we have the height of the truss, we have the truss length. So the truss length is fine at 25,000 millimeters. The only thing we're gonna change is the height and make it 3,500 millimeters. And then after that, you're gonna go to create. You're gonna start with the top chord, and then we're gonna select start and radius arc. We're going to offset it by 1,500 millimeters, and then you're going to place it like this, and then we're going to place our arc like that. And then we're going to go to create again, bottom chord. For bottom chord is going to be much easier, and then we're just going to place it horizontally like this at the length of 25,000 millimeters. And then we're going to go to create again, and we're going to create our web. So for our web, we're just going to place vertical members like this. And then you're going to select this one, AR on your keyboard, or array, or you can just go to array, and then you're going to array it towards the middle reference plane. And then you're just going to change this to 10 so you can have these 10 members. So obviously you're going to select one, right click, select all instances visible in view, and then you're going to ungroup them. So we're just going to manually adjust them so that they can be attached towards the top chord of our truss. So we're going to select all of them except the one in the middle and the one at the end. And then actually the one at the end, we can also select it. And then you're going to say mirror pick axis, pick the middle reference plane, and then everything is going to be copied to the other side. Now you can load this into your project. I'm not going to save this. I already did. Actually, let's just save this. So I'm just going to go to the VDC space and Pedestrian Bridge. So I'm going to save this as the VDC space and then truss frame. Save. So everything I've created on this, you can actually get it from my Patreon. So make sure you check my Patreon, and also make sure you join my membership on YouTube. I post content like this, but I take it much further. So anyway, we're just gonna place our truss. So from this abutment towards this abutment, we're gonna place our truss. But the one thing we're gonna do is, if you go to the 3D view, this is actually how it looks. But we want to change the members. So I'm gonna go to insert and say load family, metric library, structural framing, and then you're gonna go to steel, British standards, and then you're gonna go to square hollow sections, and then you're gonna say open. So the member we're gonna load in is gonna be 250 by 250 by 10. So it's gonna be this one, square hollow section, and then you're gonna say open. So we're gonna select our truss, go to edit type, and then the top chords, vertical chords, everything, we're gonna change it towards that member. So you're gonna make it 250. So this one 250, and also this one 250, and also this one we're gonna make it 250, apply, and then okay. So everything is gonna change like this. So by the way, this is just level of detail 300, so we're not gonna do connections, so or weldings. So we're gonna go to level 0 again, select our truss, and then we're gonna copy it towards the other side. So from this center line, we're gonna copy it to the right by 1250, and then I'm just gonna say pick mirror axis, and then I'm gonna mirror it towards the other side, and then remove the one in the middle, so it looks like this. So let me just select this, right click, maximize 3D extend, maximize 3D extend. So the next thing is we're gonna model our members that are gonna be set at the bottom, that are going to be balancing our composite slab. So in order for us to do that, you're gonna select this very same truss, go to edit family, and then you're just gonna select everything, go to filter, and then you're gonna uncheck the reference planes, and then you say okay, and then remove uh, every member that you have created. So in this instance, we are creating the bottom members, so which are going to be set on the flat plane. So think of the truss height in this instance as the width of our bridge. So we're going to change this from 3,500 millimeters to 2,500 millimeters. And then you're going to go to create. And in this instance, we're not going to create the members which are going to be running at the boundaries. So we're just going to use webs, and then we're going to start from this point, and then we're going to place another diagonal one at an angle of 45 degrees. So we're going to select these two, and then we're going to copy from this point, and then so on until the end. So we're just going to select all of these and say copy. Place them like this. Now they fit perfectly, and we are missing one, so I'm just gonna select my web again and then place it like this. So I'm gonna load this one in. I'm gonna save it, but I don't want to override it, so I'm gonna change this one to bottom members and say save. Now it's loaded into our project. Let's go to level 0. I'm going to place it from abutment to abutment like this. But remember, we have to change its orientation. So you're going to select it. Under structural properties, you're going to change the rotation angle to 90 degrees. And then it's going to be set like this. Now, one thing you're going to do is you have to adjust it. So from the middle, you're gonna have to adjust it. So you're gonna select it. So you're going to select it from the middle, and then you're going to adjust it and place it like that. So if you go to the 3D view, this is actually how it looks. So obviously if I go to let's just go to our floor plan again, and let's just adjust it again. So you're going to adjust it like this. So I think that pretty much looks perfect now. So now the next thing is we're gonna model our composite slab, and in order for us to do that, but before we model our slab, let's just place our rocker bearings. So if I go to insert and load family, so remember the tutorial we did when it comes to the rocker bearings, that's where you can get this family from. Or if you actually don't want to watch the full tutorial, you can just go to my Patreon and get the family. So if I go under pedestrian bridge, that's the rocker bearing that we have generated. So I'm going to go to architecture component, and then we're just going to place our rocker bearing. So it's going to be 500 millimeter offset from the center line. I'm going to select it, mirror pick axis, and then it's going to be mirrored like this. So obviously I'm gonna press align, and then I'm gonna align it towards the bottom of our members. And it's gonna be set like that. So I'm gonna select the two of these, go to level 0, and then I'm gonna copy them from abutment to another abutment point. So this is essentially what we have. Now let me just change this to realistic. So the next thing is we're gonna model our composite slab. So in order for us to do that, you're gonna go to structure, and then you're gonna go under structure, you're gonna go to floor, and then we're gonna use the third option. By the way, I'm using Revit 2024, so we're gonna select this one, and then I'm just gonna go with pick lines, pick my lines, so that I can place my composite slab. And then I'm gonna say trim and extend, finish edit mode, go to the 3D view, and then I'm just gonna say align, and I'm gonna align it on top of our members. So this is our composite slab, and now essentially we are done. We are almost done with our pedestrian bridge, and the only thing left is for the walkways and the railings. But one major thing, the abutments. So for our abutments, let's just go to level 0. For our abutments, we're gonna go to file and say new and family, and then we're just gonna use a metric generic model and go to the front elevation. So on the front elevation, let's just establish our height. So we're just gonna make it 3000 millimeters. Then from there, you're gonna go to reference level, create extrusion, and then you're just gonna place a rectangle, a random rectangle like this, and then you're gonna adjust it from each side. So from this side, we're gonna make it 1500. Overall length, we're gonna make it 3000 millimeters. And then from this point, I think we can make it 450. And then from this point, I think we can make it 250. Gonna say finish edit mode, go to the front elevation, place it like that, and then lock it. Go to reference level again, say create extrusion again, and then you're gonna create another wall on top of that abutment. So we're gonna offset this one by 250. And then this side also 250. Then this side we're gonna offset it by 200. So let's just measure how much this is. So this is 500. I think that's fine. Then you're gonna say finish edit mode, go to front elevation, and then you're gonna select that very same extrusion, drag it upwards, lock it, and then its depth or height, you're gonna make it 300 millimeters. So if you open up the 3D view, this is essentially how it looks. Now the only thing left you have to do is to model the wing walls. So in order for you to do that, just press VR, and then for view range, and then set everything to unlimited. Set the cut plane to 6000 millimeters, which is going to be above the entire abutment. And then you're going to say extrusion. So from this point, you're going to model your wing wall at an angle of 45 degrees and length of, actually before you do that, let's just place our reference planes. You're going to place your reference planes at 45 degrees, and then you're going to name this one A. You're going to select it, mirror pick axis, and then you're going to place a section line on this point, which is going to be parallel towards the reference plane, and then open up that section. Go to create extrusion, set the reference to reference plane A, and then you're going to start from this point, take it downwards using the entire height of the abutment, take it to the right by 5000 millimeters, go up by 1002, and then you're going to make it diagonally until you reach this insertion point, and then you're going to join it like this. Finish edit mode, go to the 3D view, and then you're going to extend its thickness like this, And as you can see, we have this. So as I was saying, for our king, as you can see, we have this thing. So we're just gonna increase the depth of this side wall by 50 mils. So we just let's make it 350, or let's make it 400. That's fine. And then let's join this wing wall, join everything. And I'm gonna select this wing wall, go to reference level. Then I'm gonna say mirror peak axis, then change the thickness of this wall to 400. Go to the 3D view, and then I'm just gonna join these with this. So obviously the last thing to do is just gonna apply material to this. So you're just gonna type in concrete, scroll down, say concrete cast in situ, apply OK, and then you're gonna load it in. So I'm gonna save this as the VDC space apartment, save, and then I'm just gonna place it right on this point, and I'm gonna use the space bar to change its orientation. And also on this part, go to the 3D view, then attach it towards the bottom of our rocker bearings from this point. And also this one align, so I'm gonna align it towards the bottom of our rocker bearing on this point. So yeah, this is essentially our pedestrian bridge model. For your walkways, like I said, you can use floors. So let's just, I'll just do a small part of it. So you can go to structure and say floor. And then I'm just gonna change this to edit type and say duplicate, okay, edit. So I'm just gonna remove the metal deck and be left only with the concrete material. And then I'm just gonna place it at 10,000 millimeters and a width of 2,500 millimeters essentially. So let's just align it like that. So the width is going to be 2,250. I think that's fine. And then I'm going to say finish edit mode. And let's just mirror it towards the other side. Open up the 3D view, go to architecture, railing, pick lines. You're going to pick lines. You're going to pick the edges and say okay. Pick the new host, and then it's going to be set like that. Go to railing again, pick lines, pick the edges, finish edit mode. So this side, railing, pick lines, pick the edges, finish edit mode, and do the same thing on the other side. So yeah, this is how it looks. This is essentially building a simple pedestrian bridge using system families and also some uh, generic family modeling, and also using customizing your own truss frame so that yeah you can use it for your truss and also your supports. Like I said, for the rocker bearing, I'll leave the link in the description towards that tutorial. But again, you can get the file on my Patreon, so make sure you subscribe to my Patreon, and you can actually get these files from there. And also make sure you join my membership. I take these kinds of tutorials much further. I'm going to be covering some different softwares such as Bentley Bridge Modeler or Open Bridge Modeler. So stay tuned and make sure you join my membership. Uh, Thank you guys again for watching, and I will catch you on the next tutorial. Peace.